So we've got this rational function and we're to find the asymptotes. So for vertical asymptotes, we set the denominator equal to 0, find out where the function is undefined. So x squared plus x is the denominator. This could then be factored. Set it equal to 0, and we get two possibilities for x. X is equal to 0, x is equal to -1. Then what you do is look at the most powerful term in the numerator, the most powerful term in the denominator, and if they are the same, like an x to the fourth compared to an x to a fourth, if it was that, then you've got a horizontal asymptote. Otherwise, if the one down here is smaller, then that means this polynomial will divide into that polynomial, and what we get is what's called a slant or an oblique asymptote. So take x squared plus x and divide it into 4x to the fourth plus x cubed minus 5x squared minus 9. So if we have a 4x squared here, and you multiply it with x squared there, then you get 4x to the fourth. Or, in other words, you look at this, and you look at the first term, 4x4, divided by x squared. When you reduce this, what's left is 4x squared, so that's what you put here. Then we have to distribute, so this times that is the 4x to the fourth, then this times this will be plus 4x cubed. And now subtract. So when we subtract, these cancel, that was the whole idea. Over here we've got an x cubed minus 4x cubed, so that's negative 3x cubed. And then bring down this term. So this has two terms over here, so this over here should always have two terms. So minus 5x squared, you bring it down, and we're almost done. We then put minus 3x, so that this times this one will be negative 3x cubed. Again, distribute, so this times this is negative 3x squared, and then subtract. So the x cubes will cancel, and for the x squares, this is going to be negative 5x squared, then this is positive 3x squared, that leaves behind negative 2x squared. And then we only have one more step, and that is, how many times will this divide into that? So we would need to have a minus 2. So distribute that. So over here we've got negative 2x squared minus 2x. And then you don't have to find the remainder. So this last step right here would be to find the remainder. But I found our asymptote to be actually a parabola. Y equals 4x squared minus 3x minus 2 is that asymptote. And then there's these two. So then a quick sketch of the graph. So we should have an asymptote at x equals 0, that is the y-axis. So I put a dotted line there. And at x equals -1. And then we just graph it and see what it looks like. So you've got y equals, and I need parentheses, 4x is to the fourth plus x is to the third minus 5x squared. Oh, I don't like when they do that. Okay. and then plus x is to the third minus 5x squared minus 9, and that's divided by x is squared plus x. And then we might need to zoom in to see what's happening in this area. So you can see right, oh, I'm sorry, thought I had that on the screen. You can see right here, as it goes down, it's getting closer and closer to the x-axis. Over here, it's getting closer and closer to the vertical line x equals 1. So on this side, it's going down. And on this side, it was going down. But then, what happens in the middle? So what happened in here, for example, when x is equal to a negative 0.5, so trace, when x is a negative 0.5, oh, it's actually up here at 40, so I need to change the window to go up to at least 40. Okay, so what happens is there's a little piece of the graph that looks like a little parabola there. So it's up there. And now for this part right here, if you zoom way out and you compare with the graph that we got, 4x squared minus 3x minus 2, and I will make that one a dark line. Then, if you zoom way out, like have this be negative 100 to 100, negative 100 to 100, then it should basically look like a parabola. Wow, it's much skinnier than I thought. So x's actually don't need to be that big. Negative 10 to 10. Okay, so we're talking about this part out here. Oh, there it is. There goes that parabola. So we got it right.